Okay, let's do another problem. Let's say that we've got a child going down a slide. So, example, child going down a slide. Or it could be an adult, it could be you down a slide. It could be a water slide. And let's say that the slide, oops, that was a poor drawing. Let me pause and do. Okay, so I've got a child, a box shaped child, going down a slide and accelerating down the slide. Let's say that the child has a mass of, let's use 40 kilograms again. That seems like a good small mass for a small person. And let's say that there's friction. The friction opposes the sliding child. Let's say that the friction is, I don't know, just make up a round number, 120 newtons. Okay. Oh, and I didn't say, but I drew that the slide is at an angle of 30 degrees. Let's just make it a flat slide, or what we often call an inclined plane. But just a plane that is at an angle of 30 degrees. Okay. Then what question are we going to ask? I think the only questions we can ask, if we're doing a Newton's second law problem, is what is the child's acceleration and what is the normal force, the force that the slide exerts perpendicular to the surface on the child. Okay, so how do we do this problem? Well, step one, we drew our diagram. Step two, we are going to draw a free body diagram. Okay, now one of the things that I do, and I would suggest that you do, is to always draw your object in its correct orientation. It helps you draw your free body diagram. So I'm going to take the child of mass m, and I'm going to draw it as a box on an incline, but I take away the incline. Now we ask, is it touching a surface? Yes, it's touching a surface, so the direction of the normal force must be perpendicular to the surface, and that's how drawing the child on the incline shows you the direction of the normal force. So we go through our forces. Is there a rope attached? No, so there's no tension. Is there friction? Yes. And what's the direction of the friction? Think about it. The frictional force should oppose the motion. So in this case, the frictional force should be up the plane, F friction. Okay. Then is there spring attached? No. What am I forgetting? Is there gravitation? Yes. Is there? Does the child have a weight? The answer is yes. And what's the direction of the weight? Careful. What's the direction of the weight? It's not perpendicular. It's not in the opposite direction of the normal force. It's straight down towards the ground. So it has a weight equal to the gravitational force. Is there anything else touching the child that could exert a force on it? No. The only thing touching the child is a surface. And the only thing a surface can exert on something is a normal force and a frictional force. Okay, so these are all the forces. This is our free body diagram. The next step is to choose our positive directions, x and y directions. Now, be careful here. Remember that it's going to make your life easiest. You can choose the x and y directions any two perpendicular directions you want. You can draw them anything that you want. But in this case, it is not going to be fortuitous. I don't know if that's the right word, but it's not going to be easiest to draw them horizontal and vertical because the child is not moving horizontally or vertically. They're moving down the plane. So if we chose horizontal vertical, we could absolutely do that. But notice we're going to have to take components of Fn and Ff because neither of them are in the x or the y direction, although we wouldn't have to take components of Fg. We can actually make our lives easier by, again, choosing the plus x direction to be the direction of the acceleration. And so we choose the plus x direction to be the direction down the plane. That's my plus x direction. And so then my plus y direction is perpendicular to that. If you have trouble drawing it, simply turn your paper. I'm actually taking my iPad and I'm turning it so that I can draw those as if they look horizontal and vertical, and then I turn it back in there at an angle. Okay. Oh, and by the way, I'm sure you noticed I'm in the lower right-hand corner. I didn't used to be. Hello. Okay. So, so those are my positive directions. And plus y I chose up from the plane. It could have been down from the plane. It doesn't matter. But it's just, whatever. It doesn't matter. I just chose up from the plane. Okay, so that's the third step, choose the directions. The fourth step is to write down the relationships we're going to use, right? We're going to use F net x equals M A x F net y equals MAY. I know that so many of you are not going to write these down, are going to start writing down numbers, but you have to write down the relationships that you're going to use so that I and you know what you're going to use. Writing down numbers is not helpful. And notice that I never, ever write numbers until I get to the end. You always solve using letters. Never, ever write numbers till you get to the end, till you're done solving, and then you can plug in. Okay, so here's the cardinal rule. Never, ever, ever write down numbers until you are done solving. Once you solve for what you're looking for with letters, then you plug in numbers. That's going to be your last step. Now, you might ask why I'm writing this in rainbow colors and yelling this at you 5 times. It's because it's the only way to solve the problems. By writing numbers down, you're not doing any problem solving. You are just you are random. I mean, in the end, what happens is that you're trying to manipulate numbers in a way so that you can get an answer, but you're not solving the problem logically. When I'm solving this is not a punishment. It's not a punishment asking you to solve things with letters. It is the only way to do it, and it's the only way that you're going to get the right answers. And it's the only, and I tell you, the most important thing is probably it's the only way I can grade you. I can't grade a series of numbers. I don't know what you're doing. I can only tell what you're doing if you're writing down relationships. Okay, so back to the problem. Whoops, I got to change my pen back. Okay, so we were saying that the next step was to write down f net x equals max, f net y equals may, and then the next step is to identify. The next step is to identify the left-hand side, right? Identify the net force from the free body diagram. So this was step 2, this was step 3, this was step 4, this is step 5. Identify the left-hand side, the net force from the free body diagram. Okay, so now we may have to take some components. So we're identifying F net x, right? F net x. Which of the forces have an x component? Look carefully at your free body diagram and your axes and ask which of the forces have an x component. Fn is in the y direction. Ff is in the minus x direction, so minus Ff. And Fg has an x component in the plus x direction. Look at Fg and look at the x-axis, and you can see that Fg has a projection along the x-axis, which we'll draw in a second. But I'm going to write that as plus Fg sub x. We can take the components at any point, but I'm just going to write it as the x component of Fg. Okay, that's F net x. And F net x, so keeping with step 5, equals max. F net y, right? Looking at your forces in the free body diagram, look at the diagram, again, Fn, Ff, Fg, which have y components. Fn is in the plus y direction, Fn. Ff is in the minus x direction, so it has no y component. Fg has a component in the minus y direction, so it's minus Fg sub y equals ma sub y. And if you don't see that, wait until I draw the picture of Fg and Fn and Ff. Okay, but this is step 5, identifying the forces from the free body diagram. So now we've got Newton's second law, and then step 6 is going to be to identify anything we know about m's, and a's, and then step 7 is solve for what we don't know. But before we get there, before we do step 6, let's go ahead and look at the components of these forces. Okay, I redrew the free body diagram, just redrew it and put my axis directly on top of it. And notice that my x-axis is along the ramp. So my x-axis makes a 30-degree, because we said that the ramp was at a 30-degree angle to the horizontal, x-axis makes a 30-degree angle to the horizontal there. So now look at this diagram and see that Fn only points in, right? Fn only points in the y direction. Ff only points in the x direction. But we have to take components of Fg. So what color should we make the components of Fg? Let's go ahead and make them purple. So we have an x component and a y component, right? And the x component is the projection in the x direction, pointing in the direction down the plane because Fg points in that direction. And then Fy points so there you go. Fx and Fy, the two components, the two projections, and Fx and Fy need to add to be Fg. Okay, so this is FGX, and this is FGY. Now, 30 degrees, now careful here. Notice that, how can I show this? I wish I had a laser pointer here. Okay. I'm going to go ahead and point at it and then erase it. Okay. So this 30-degree angle right here, whoops, that was bad. That 30-degree angle, it's hard to see exactly, but if you look at this, the triangles or similar triangles, that 30-degree angle is the same as this 30-degree angle. Sorry, is the same as this angle. Stop, hold on a second. Okay, so the 30-degree angle that the x-axis makes with the horizontal, that by similar triangles is the same as this angle inside, the angle that the y component makes with FG. The other way to look at it is, and I'm going to draw this and erase it, the other way to look at it is that this big triangle, whoops, this big, come on, this, hold on. To look at it is this red triangle that is overlaid on this, and see that since the bottom angle is 30 degrees, this top angle must be 60 degrees, right? Because this is a 90-degree angle. And so the top angle is 60 degrees, so that means that the other angle in the littler triangle must be 30 degrees. One way or another, you got to do the geometry and look for similar triangles and figure out which angle is which. So looking at that, looking at the triangle, you can see that FGX is equal to FG times the cosine of 30 degrees, and FGY equals FG times the sine of 30 degrees. One way or another, you've got to do that geometry, SOHCAHTOA, figure out which is which. Except that I just wrote that completely incorrectly. Darn it. FGX is the opposite to the angle. So I made the same mistake that you're going to make sometimes, is just use the standard, right? X is cosine, Y is sine. That is not true. It depends on which angle we're looking at. So anyway, so the sine of 30 degrees is opposite over hypotenuse. Cosine of 30 degrees is adjacent over hypotenuse. So we get FGY is the cosine of 30 degrees times FG. Okay. So now we go back to Newton's second law that we had filled in, and just fill in the right-hand side and then solve for what we're looking for. So this is what we had, and we know that FGX is equal to FG sine 30 degrees, or sine theta given. FGY is FG cosine 30 degrees. We know that the mass of the child was 40 kilograms. We know that the acceleration down the ramp, a sub x, is what we're looking for, and the acceleration perpendicular to the ramp. We chose the x direction to be the direction of acceleration, so the acceleration perpendicular to the ramp is 0. And so then we can just go ahead and plug in and solve, right? So, and we were given FF is equal to 120 newtons. So we can then go ahead and just plug, and we can go ahead and plug in and solve. So we can take FG, the first one, and say minus 120 newtons plus FGX, which is, FG. What is FG? What's FG? Well, it's just mg, right? FG is equal to mg. So we know that this is mg sine 30 degrees. FG is just the weight. By definition, FG is the weight. Mg cosine 30 degrees. Okay, so FGX is the mass, 40 kilograms, times g, 9.8 meters per second squared, times sine 30 degrees, equals m, 40 kilograms, times a. So now we're just plugging in numbers. Now it's just calculator, plugging in numbers. And then the second one, same thing for the second one. For the second one, Fn is unknown, plug in FGY, and a sub y is 0, so we get that. And so the first one we can solve for a, second one we can solve for Fn, just plug it into your calculator. There's no need for me to give you a number. A is 5, Fn is 7. I don't know, whatever your calculator gives you, whatever those numbers give you when you plug it into your calculator. Okay, so that's the last step in the problem solving process. Just solve for whatever's unknown.